we are going to get started on schedule. Our first speaker is, so just before that, so yesterday we had a wonderful introduction to what has been done in the past and what is actually going on around India today, related to what we see as the difficulties or the opportunities. But also we see that although there are many things going on, there is an opportunity to combine these things into revolutionary change. So today we'll be talking more about the solutions and we'll go into some outrageous technological concepts and other things to say how can we introduce really dramatic and revolutionary changes. And tomorrow it'll be mostly about the detailed implementation. So our first speaker today is Professor Satya Chakravarthy. He is the force behind the organization here. He is a graduate of IIT Madras, B.Tech in aerospace engineering. He came to Georgia Tech, where he got a master's and PhD in aerospace engineering combustion. So he is a true disciple of the rocket scientists in the United States. And he then came back to the IIT, and he's now, among many, many other things that he has done, he's one of, at least, are you one of the leaders or the leader of the NCCRD?
Doesn't matter.
Okay, all right. So he's the leader of the National Center for Combustion Research and Development, which has grown into the largest such academic center for combustion research. So without further ado.
Thanks, Professor Komarath. Good morning to all of you. I'm pretty glad to be here, and thanks for the opportunity for me to speak on a topic that doesn't actually exist in the dictionary yet. Okay. So I'm going to talk on something called defrastructure, and we need to actually think about what that means. So development, like for example, how India should develop or a developing country should develop or whatever it is, has been predicated on massive investments on infrastructure by governments. Again and again, governments are goaded to spend more and more money on infrastructure projects, right? And modern infrastructure is mostly extremely massive. So you look at these. High-speed trains is something that we are just about doing. China has actually overtaken everybody else doing that in just the last couple of decades. Fiber optic networks, refineries, telephone lines. This is not any particular order, but all these things are in a very ugly manner, very, very massive, right? So highways, fighter aircraft, water pipelines, power lines, power stations, drainage lines, airports, ICBMs, city gas lines, crude gas pipelines across continents, sewage lines, solar farms, oil tankers, space launchers. This is not exhaustive, right? And as Professor Bhaskar was saying yesterday, we actually take all these things for granted. So if you want to actually now say, providing urban amenities to rural areas, how am I going to do all these things in rural areas? How am I going to actually do the last mile connectivity and all of that, right? Is it really sustainable to do it this way? So this really puts a gun on our head, right? So if you sign up for the development agenda on terms set by the developed world, you're a loser right away. I mean, it's a no-brainer, right? So we shouldn't be just doing this at all. That's essentially the point, right? So what is the way out? So you have to ask the question, is this really what we need to be doing, right? You have to turn the question on its head. So the question we have to ask is, do we need massive infrastructure, right? So can we look at an alternative model of development, right? And this alternative model of development is not something that's going to be very prosaic. It has to be new. It has to be very small, because that's what we are basically talking about, right? Smarter tech. It's actually going to be extremely difficult to do this kind of technology, right? And maybe really, really high tech, as we will show, right? We will bring rocket science down to the common man and then say we will actually do a much better job than anybody else. How do you do this, right? This requires less capital investment, right? It is extremely distributed. It is very modular. That means you can keep on adding this and then grow. And local decision making, right? If a panchayat wants to launch a satellite, right? Can we do this? That's a question, right? So participation in the cleanup. So when all these things are actually happening and you get your power from somewhere else where the coal is actually burning, you don't really care. But you have to actually burn your own coal and produce your own electricity, you will care. We try to put a nuclear power plant and then people say, NIMBY, not in my backyard, right? Where do you get the power? You can go tell them, go find your power. And that's what we want to do here, right? So And a lot of times, it's all about going back to our roots, right? I mean, India has existed for about like millennia. We have figured out all these things in some sense, right? And we have been continuously going through progress. How did we do it? How did we do it in a sustainable manner, right? So we have to actually think small and grow big, right? That's essentially the way we have to start thinking about this. Now, when we now talk about this, Small is Beautiful is a beautiful book that came up in the later part of the 20th century. I don't know how many of you have had a chance to read this. It's an amazing book, right? So this basically espoused the idea of distributed small work centers, right, as a model for developing countries in the 20th century. It's a Gandhian idea. E.F. Schumacher did a brilliant piece of this book, trying to actually exactly say what it is. Now, the problem essentially at that time is the advanced countries were getting entrenched in these large technologies, right? Large power plants, large airports, large whatever, highways and stuff. So people like Gandhi or Schumacher couldn't even imagine, right? You can actually do the same tech in different ways. We now, I'll show you, we have now tech in the 21st century which will enable us to do what we are talking about, right? So the small work centers were basically technologically inferior. They were supposed to be labor-driven because you want to actually give a lot of people jobs and all of that, right? So they were actually supposed to be technologically inferior. Unfortunately, today, we can't accept it, right? So most Indians have actually graduated from fans to air conditioners, right? So you can't now go and say, let's do an inferior lifestyle, okay? That's not acceptable. So we need to be technologically superior as well. We have to get real about this. So there was another book that I came across very recently called The Innovator's Dilemma, right, by Clayton Christensen, which exactly defines what is called as disruptive technology. And today, the technology disruption is being bandied about. Right? So people don't even think what exactly is technology disruption. Please go read that book. It actually defines what technology disruption is. This was actually in the 90s, right? So Christensen basically says, start with an inferior technology, all right, and push it into a new market. So when the big technologies are actually growing like that, the market needs are actually only within this band. People just accept the technology that's available, and then their expectations on the technology is actually growing at far less rate when compared to the technology can grow itself. That is exactly the premise here. Now, if I try to do a technology disruption, bring the cost lower, come up with an inferior technology, right? Cell phones were actually inferior technology when compared to landline phones, right? But what happened in the end, right? So we now can grow in the same path as that and then catch up to the mainstream market. So today, if I actually develop a technology that's good for India and Africa, America will actually take it about 20 years later. That's exactly what we want to do, right? So what gives? We question the assumption that massive infrastructure is needed. We disrupt with new, smarter, small-scale, deep, and high-tech that obviates the need for only massive infrastructure. In fact, it would even necessitate the dismantling of existing infrastructure, right? People should be ashamed of using very big infrastructure. You go stand in a security line in an airport, you should say, shucks, why should we actually go through this, right? So we call it defrastructure. So let's give a couple of examples. These were actually mentioned yesterday in talks by Professor Bhaskar and Ashok Junjunwala, right? So mobile phones overtaking landlines. We just talked about this just a minute back, right? And so it's now a no-brainer to think about this. Why were we talking big time about EVs? The answer essentially is it's 100 times fewer moving parts. So it's much easier to maintain this. It can be much cheaper in the long run, and Tesla is offering like infinite mile warranty, right? So there is some reason why we now just try to simplify the entire technology by going EV, right? The other thing that people don't realize is the Uberization is actually a defrastructure, right? So cars for about a century have been the least utilized product in the world. They're used only for about 4% of the time. The rest of the time, they're actually being parked somewhere. And many times, we're actually finding it so hard to park the car, find a parking space and stuff, right? It just doesn't make sense. So what you do, you actually hail a Uber or Ola, right? Or Lyft in the United States, right? So what does that mean? extreme amounts of parking lots and parking decks simply become obsolete. So we don't need parking lots anymore. We can just use that kind of land for a lot of other purposes. Grow trees, for heaven's sakes, right? So defrastructural advances in information, communication, and electrical technologies are really amazing. That's what's actually been happening in the last 10 years. But what about mechanical engineering hardware? That's where I come from, right? We need to worry about that because most of the stuff that we actually go through are mechanical engineering, right? So things that are like really, real hardware, okay? So what do you do about that? Engines, trains, planes, rockets, right? Before the end of the talk, we will talk about how to actually Uberize rockets, how to actually go, say, have a Uber for space launches, right? And that would be what Kalam would want today than what it was last century, right? And of course, a lot more mundane things than these, right? So I come from aerospace background. I talk about planes and rockets and engines, but there are lots of other things like water, right? So more important things, right? Okay. So that's where we need to come to NCCRD, right? So NCCRD is actually the hub of deep tech startups at IIT Madras and in India. The array of deep tech startups that we're talking about, making engines, planes, rockets, right? It's not actually there anywhere in the world. We're just being modest in saying that we are the deep tech startup in India. Okay, just go check it out. I don't know anybody else who's doing this, right? So we have the E-plane company, which makes drones, hybrid drones, and electric planes, Agnikul, mini rocket launch vehicle, Aerostravelos, micro gas turbine, and X2 Fuels and Energy, which actually makes crude oil from waste, right? And recently we have had the Avishkar Hyperloop, a student competition that's gone to SpaceX right now, and more, right? And many of these are actually coming out of technology that we're developing at NCCRD and pushing it to startups because big companies just can't have the appetite to absorb these kinds of things. So let's start with power generation. So redefining power generation sets, right, but with micro gas turbines. So you can find street corners where you will find really fat, big, long diesel gensets, right? And the most important thing is they are diesel gensets. That means you can use only diesel, right? We have an incredibly fuel flexible engine that we are coming up with because it's a continuous combustion device as opposed to a reciprocating combustion device. Therefore, it is extremely pardoning on the quality of fuel as well as whatever the fuel is. It could be a gaseous fuel or a liquid fuel, doesn't matter, right? For 100 years, we have been actually told that if you have an engine, you have to put only petrol or only diesel, right? I mean, that's actually very bad engineering, right? I'm telling you, you can put gas, you can put liquid, doesn't matter. Okay, so incredibly clean. Look at those numbers, right? The expected norms are these, and then we are about 100th of those. It can actually last the next 10 years, 20 years, not a problem, right? And comparable cost to diesel gensets. That's exactly the Christiansen idea. Keep the cost down, right? And push an inferior tech if it is, but doesn't matter, right? Reduce maintenance because this is just the single moving part is basically the shaft, right? And extremely compact. So what could actually be about the size of half the stage can actually sit on something like this, right? So extremely compact gas turbine. How did it come about? So we actually worked on the swirl mesh lean direct injection burner or combustor, which has a high turn down ratio, flat part load efficiency, no instabilities, right? So when we started the NCCRD, we were asked to actually embrace grand challenges. But unfortunately, big companies don't have appetite for these grand challenges. And academics actually keep on working on a problem without actually having to find a solution, right? I mean, all these things are all like a big sham going on around the world, right? So we actually have very huge geometric novelty in this burner, which is now enabled by metal 3D printing, right? And metal 3D printing is the one that is actually the level playing field against complex manufacturing, which is a forte of advanced countries so far, which essentially means that we can leapfrog into the 21st century without much ado. So where do we use this? Smart hybrid microgrids. As you put more and more solar into your grid, you have a problem of grid stability, because you can generate a lot more power than what you want during the day, and you can't produce any power during the night, and we don't have affordable, excuse me, Paneerselvam. And we can't have affordable storage solutions today. right? So what you do, you now have a microgrid, and you now have the battery as well as a microgas turbine that can kick in at any time at whatever load you want, okay? And that's essentially what we're talking about. And similarly, in factories, if you now have combined heat and power, you use the exhaust, you can actually now get up to 90% efficiency, which essentially means we can make large power stations and long distance transmissions obsolete straight away, right? Flexible, fuel flexible hybrid could be cheaper, right? If I can actually find very cheap fuel when compared to diesel or petrol or whatever it is, and I can actually run this, it can actually be cheaper than even a full EV, right? So today EV is very expensive because you have a huge battery pack, and then Professor Junjanwala is espousing the idea of swapping. So many people then will say swapping becomes a burden, and so on. So we have a problem, right? So series hybrid EVs, right? So Ashok Leland has actually expressed interest in trying to work with us on this. Extra fuels and energy, right? So India has about 133 million tons of garbage annually, right? Whatever we produce, good or bad, we produce a lot of garbage, for sure, right? So what do we do with all of that? It's all going into landfills, right? So what do we do? But on the other hand, India has about $125 billion of crude import as of 2018. That's a huge economic burden on the country, right? So how do you actually kill two birds in one stone, right? Is it possible for me to actually take the waste and make crude oil out of it? And all of us are producing, generating waste. Can all of us produce crude oil? Sure, that's the idea, right? So all of us now become part of the productivity process, right? So we use a process called hydrothermal liquefaction. What is it? Right? It mimics nature's method of producing fossil fuels through application of high pressure and high temperature. We just take, in fact, in most of these combustion and gasification processes that involve waste handling, the first step is to actually try to get rid of the moisture. It's a big burden, right? Whereas here, moisture is a boon. If I don't have enough moisture, I'll actually have to throw in a little bit more water. And I now put it in a pressure vessel, heat up the water, and the water basically becomes vapor. It goes into about 180 bar and 300 degrees C, cook it up. It's a glorified pressure cooker, right? So there are no really moving parts except the storage, right? And at the end of the whole process, you open the tap at the bottom, you actually get crude, right? So there is lots of uses for this kind of crude. And you can actually do biomass, municipal solid waste, sugarcane, all these things have been tried in our laboratory, right? So if you're in a rural setting, you have a lot of agri waste. If you're in an urban setting, you have a municipal solid waste. If you're actually a suburb, good for you. You have both, right? So you can actually, so you now have different kinds of these waste. You now get different kinds of crude. Now, how do you actually process all of these things? Blend them together, right? So you now blend them. You actually get this commercial product that we want to trademark called X crude. It's actually crude from any X, right? So there is lots of uses for these things. We can actually blend it, first of all, with the petrocrude, start decreasing progressively our import burden, right? As we are now trying to set up these kinds of small centers that can process these wastes at small quantities, produce them, and then get them together and blend them and stuff. Look at the amount of economic activity that we can generate with this, right? And we can at once put all these oil tankers, long pipelines, right, refineries. So now, connect this back to the microgas turbine, which was extremely flex fuel, right? So it didn't require a petrol or a diesel or a kerosene. That means I don't have to actually do fractional distillation of these different parts, right? Take the crude, get rid of the slurry, get an oil. You want to call it the Chakravarthy oil, I'll be very happy, right? Right? So just an oil would do. So immediately you don't need refineries at all, right? So you just get rid of all of them. The E-plane company. We now step into transportation, right? So flight path in the E-plane company is to actually make a 2 to 6 kg payload that can go up. So all these things can actually go up to about 100 to 200 kilometers. They're all electric planes, okay? So long distance, long endurance is essentially the forte of what we're talking about. They're not just drones. They are actually hybrid drones. We call them hybrid aerial vehicles or HAVs, right? So in the future, it's going to be, do you have or you don't have? Right, that's a question. So hybrid aerial vehicles is what we're actually trying to push in this new tech, right? These are drones with wings, so quadcopters with wings. So in the future, we will actually upgrade this to about 25 to 40 kg payload for taking goods. This is for delivery, surveillance, and survey. I'll show you some applications. And do the E-plane, right? The E-plane is where we actually start doing people transport. At about 200 kgs, it's a two-seater autonomous aircraft. Well, why would we do this? We'll come to that. So the drones and hybrid aerial vehicles are pretty much in hybrid aerial vehicles are what we are trying to do, but drones is something that's very common, right? We are also making an agri drone. That's a picture of agricultural drone that we have done. Now, this leads us to what's called as precision agriculture, right? So is it possible for us to actually insist that our farmers are engineers, right? We need to actually have biotech engineers who are actually doing farming. They need to know what they are doing. I mean, they have a lot of traditional knowledge. It's possible to actually derive knowledge systems out of that and combine with, the science that they have to actually learn from those traditional knowledge as well, right? So this is now becoming an in thing. So what is the alternative? So if you had like large tracts of land that are like hundreds of acres, right? You would take an aircraft piloted and then spray pesticide, mindlessly. That's like a huge amount of pesticide that's being used unnecessarily, right? And that is actually a lot of infrastructure there for using this. Precision farming is all about taking a drone, going plant by plant in the farm, and then spray where you want, sprinkle what you want, right? And this is now being done. Now, how do you actually try to do this in India? What's the problem in India, right? In India, we have discontiguous parcels of land. Different farmers will be actually doing different crops, and people who are actually doing the same crop would want to hire this, right? And they are not exactly in contiguous parcels of land. So one land would be about 2 acres, another land would be about 8 acres, a little bit farther away, and so on. So after you're done with the spraying, you want to actually take flight from one place to the other. That's where the hybrid aerial vehicle comes in, right? You see how technology can be used to adapt to local scenarios. Organ transport. So today, if you have to actually do an organ transport, you need to have this green corridor set up where you stop all the vehicles in the traffic and then let an ambulance actually carry an organ in order to save a life, right? If I actually had the hybrid aerial vehicle cut across cities over tens of kilometers without any ado, nobody would even know that there is actually an organ transplant going on, right? That is defrastructure. This requires massive amount of infrastructure, coordination with the police, all that kind of stuff, whereas this is not. That was about saving lives. This is about killing lives, okay? And I'm an aerospace engineer. I'm application agnostic, right? So if I have to actually go to the defense and then say, take this hybrid aerial vehicle, right? Put rockets that can take like about only 2 kg bombs, right? But this one is going to cost like about some 10 lakhs or something like that. Take hundreds of these, okay? Just carpet bomb the place that you're actually talking about. Instead of taking a fighter aircraft, put a life on board in the name of a fighter pilot, risking his life. And this is like hundreds of millions of dollars worth of machine. It doesn't make sense to actually have that anymore. And similarly, you don't need ICBMs, right? Just go strike with about hundreds of these at the same time. What is the enemy going to actually shoot at, right? So it's a completely different paradigm that we're talking about when you're now trying to distribute this kind of a strike. So we're talking about all of that for the small-scale drones that can carry small payloads. What happens when you now actually increase the payload, right? Electric planes have the problem that they cannot go very long distances. You can go only about 100 kilometers or 200 kilometers if you're particularly carrying more and more passengers. So that means it's actually, so you have to find a new market. That's what Christensen says. So the new market here is air taxis, right? So you now so look at the traffic that we have. If anybody has been in Bangalore, right, you don't want to actually be there at all because you're spending more time on road than getting to wherever you want, right? So air taxis is actually the way to go for an Indian city, right? So we expect that E-planes will be very, very inexpensive, I'm sorry, right? So the number of parts and complexity of operation is drastically reduced, very similar to EVs, right? Could push a lot of E-planes into the market, and this is essentially cars with wings and rotors, right? So it's perfect for sub-regional, suburban, rural micro-aviation. You can, because if you now get into VTOL, for example, as we will see, right? Right, you can actually go take off and land anywhere. And if you're using conventional runway planes, we can actually make circular runways. You don't need these very large pieces of land that is actually occupying a huge parcel of land around which the city has to grow. I mean, look at Mumbai. If you want to go from one terminal to the other, or Delhi, the T3 to T1, you have to go around, right? But they're actually having only one runway. They have terminals on opposite sides. Okay, that's bad. So you're actually occupying a lot of space, right? I can have one of these things outside of IIT Madras, right? And I can actually take off from there. I don't have to go anywhere, right? So VTOL, right? The other way of actually doing this air taxis, I want to actually have a plane come and pick me up from my rooftop or my doorstep or my street corner. That's exactly what I should want, okay? So, and I just dial in a Uber and then it just comes. And it's an autonomous flight, right? There is nobody who is actually driving it, so piloting it. So there is a lot of these kinds of things that are emerging, right? And we are in that game as well. So the next big thing then is, when you have to pay attention to this is really cool stuff, right? So if I can actually do an inverse swarm, let's say I want to go from my home to Bangalore somewhere, and I don't go anywhere, I just step out of my home, a VTOL comes and picks me up, right? But it's scheduled in such a way that as it flies out of Chennai suburbs, there is a mothership that will actually go, be going from some airport that I don't go to at all, right, to some other airport in Bangalore, right, that we don't go to at all, right? But we just hitchhike a ride on it for getting mid-air recharging, right? So you just keep on getting mid-air recharging and get these big flights to go, which are essentially like a skeletal aircraft where maybe piloted, may not be piloted, I don't even know, but it generates power, just spews power onto all the customers that are getting tagging to it, right? So we could actually run this recharging mothership. Airlines will not have those, really, what should I say, sexually inappropriate air hostesses anymore. I mean, they don't need all of that, okay? So, because they will just be running a skeletal airplane, which is hardly like a plane anymore, right? And these are airports that we will not go to. So we won't go to any airport anymore, no more security checks, nothing. You just get off from your doorstep, get on to wherever you want. So the eVTOLs and the planes essentially mean ubiquitous flying. Everybody should actually be flying. You should get on a plane from where you are to go where you want, right? If you do this, you don't need these massive highways anymore. You can actually have whatever really bad roads, very bad landscapes, and all of that. It doesn't matter. You just want to go wherever you want, just go there, right? So we'll make airports obsolete. We will actually make highways obsolete. Hyperloop. It's not as if like we're actually low-tech at all, right? So fifth mode of transportation, right? So when compared to air, sea, road, and rail, so we now can actually go the fastest because we are trying to get rid of any kind of friction, right? So just have a tube that will be evacuated and have magnetic levitation so that you don't have wheel friction anymore, right? So you can actually have a propulsion by linear induction motor from station to station. So we have this Avishkar Hyperloop that's actually now gone to Hawthorne, California for the SpaceX pod run competition, which is, right? So if you now look, and we've done the calculations for what it takes for actually going from here to Bangalore. 16.5 minutes to go from here to Bangalore. Downtown Bangalore, not Devanahalli. Okay, so you can actually get to Bangalore. So that means like you don't have to actually live in Bangalore if you want to work in Bangalore. You can actually live in Chennai. Okay, so something that you can, and we try to actually get the ticket price to be very, very affordable. Okay, now if you think that I can't pay this every day, I think most of us are actually paying these kinds of things to Uber anyway. So we have the team that's actually won the Asia's for the only team that got into the pod run competition. So we got the pod, but these competitions can actually distract you. So the competition is all about running a pod, but the trick is actually on the tube. Right? So the tube is the one that's going to be the massive infrastructure item. So if I have to actually run a vacuum tube from here to Bangalore, how am I going to actually do that? That's essentially what we should be worried about. So the good thing is this tube doesn't have to be extremely perfect. It doesn't have to be having perfectly aligned rails like how a high-speed rail requires. And the high-speed rail is actually extremely expensive, because the pod is not coming in contact with any rail or the tube. The tube can be a little bit this way, that way, it's okay, right? So long as we have enough room right? And you're going to evacuate it once. We now try to keep the vacuum, and all the maintenance is all about keeping the vacuum, and you don't have to evacuate it every now and then. You can have vestibules in stations between the pod and the outside, so we can maintain the vacuum. So we have to basically leapfrog onto the Hyperloop and give the high-speed train a miss, essentially. Just don't even do high-speed trains, just go ahead and do the Hyperloop, right? So we can make these obsolete. And think about it, China has been spending an enormous amount of money on this, and then you tell them, no, sorry, I think we should do something better. So Agnikul, the rocket launch vehicle, that tagline, and we take every word of this very seriously, launched rockets anywhere, anytime, affordably, right? So the anytime bit is what is Uber, right? So you want to actually bring a satellite, you bring it to me, and I will do a 3D printed engine stack, and then make this rocket in about a week's time, meet the satellite, and launch it. And I can actually launch it anywhere, is basically the claim, right? And we'll talk about that in the next slide. So we basically have a 3-stage rocket launch vehicle with a payload capacity of about 100 kgs. Now, why is this important, right? And what is the kind of tech we are talking about? So if ISRO is actually making a PSLV that can take 1,500 kgs, and then they over-designed it for some reason, and they could take only 1,400 kgs, that's okay, right? But if I'm designing a rocket that's supposed to take 100 kgs, right, I better take 100 kgs. Otherwise, if my tech is pretty bad, I'm actually going to go down to 0 kgs. It is not good. So my tech has to be very, very good. So it's not like a third world rocket. There is nothing like a third world rocket. Gravity is the same regardless of which part of the world you are, right? And we are beating gravity to go to space. So here we have lots of other possibilities of launch, like balloon launches. You can actually take a barge and go to the equator and launch a balloon from there and stuff. There are all kinds of things that are possible, right, with modularity. So this is a hugely modular rocket. So you just have only one engine primarily that is designed. We just copy, paste, and print it again and again. And we work out of containers. I mean, these kinds of rockets can be launched out of trucks, right? So we don't need these massive launch pads anymore, right? And you can actually pick any place on Earth which has the access to equator or to the poles, right? So long as there is no landmass in between which is inhabited, so that the debris doesn't fall on anybody, right? And there are many such places around the world, and you can actually go to any place, take your rocket, and launch in quick time. So we'll just operate out of about 3 containers and launch from anywhere. So make launch pads obsolete, right? Now, ideating, just a couple of more slides here. So we're looking at standalone toilets. So many times we think that we need to actually do biomethanation of whatever excreta and so on. So we actually try to put this out. This is actually Professor Indumati Nambi working with me. And we try to actually put it out to the army. But in cold climates, high altitudes, and all of that, biomethanation takes like very, very long time. It's an extremely sluggish process. And that means that if you have to process that, you need to have very large pits that you have to create and stuff. That is kind of infrastructure. Is it possible to actually have standalone toilets which has like a mini chemical factory running behind, okay, processes stuff, right? So we could actually use, again, rocket science. Aluminum water reactions happen inside rockets, right? Is it possible to actually use that to react with urine and produce hydrogen, and then react it with atmospheric oxygen to produce very clean water, right? So is it possible for us to actually recycle water out of our own urine? Sorry, boss, but this is actually very clean. We are actually dismantling the atoms and molecules, reconstructing them again, right? So it's not the same water that it's not purification of your urine. We are actually making new water out of it, right? And we can, of course, do this with saline water, so there is a desalination possibility as well. The crux here is to recycle the aluminum, and we need to look at reduced cost of the Hall-Héroult process that recycles aluminum with non-consumable electrodes. So doing this, we can actually reduce the amount of the cost of producing aluminum by about 1/3, and this makes it more sustainable, right? So the SATs and the locally recycled desalinated water, right, can actually make all this huge water pipeline network, drainage, sewage lines, all of that obsolete. You don't need any of those, right? Now ideating, again, wearable air conditioners, okay? So, of course, we come up with these personalized air conditioners. This is actually the latest product that's doing the rounds, right? And what about making it even more wearable? So if I actually have to wear a small air conditioner in my hip and then send the tubes around through my sleeves and stuff, just cool my body. That's exactly I want to do, right? We just don't want the entire CLT to be air conditioned, right? That is CLT for you. Okay, so that becomes obsolete, right? So I think we have come very close to home, so we need to stop, right? So Kennedy said this, right? Ask not what your country can do for you, ask what you can do for your country. So we basically say, don't ask what your government can do for you, just do it yourself. That's essentially what we are talking about. At NCCRD, we have a studied irreverence towards conventional wisdom. And let's develop high tech that can democratize access to high standard of living through defrastructure. Thank you very much.